Hello, this is Don with Mexsoft Corporation. Today we're going to be taking another look at Rhino3DPRINT2016. And this video will be Quick Start Guide number 2 of 3. Our first guide took a look at point clouds. This guide will be taking a look at offsetting, also referred to as shelling, and splitting. Let's take a look at the basic steps we're going to use to complete this part. First, we'll have Rhino3DPRINT launched and we'll open the part file in Rhino. Then we'll diagnose the mesh for possible problems. Then we'll use Stitch and Close to combine and fix the mesh. Then we'll use Offset Mesh to create a uniform wall thickness. Then we'll split and cap the mesh. Okay, after you install Rhino3DPRINT 2016, you'll find a Rhino3DPRINT 2016 menu item on the main menu. If you drop that down, the first thing I want to talk about is the Welcome option. Select that and the Welcome dialog will display. And what this gives you is links to resources about the product. Now, if you're not comfortable with working with videos to work with tutorials from a video, you can get this same Quick Start Guide in a PDF document just by selecting that option, and it'll display the PDF document for you and you can work from there. Okay, let's close that. Also, from the Rhino3DPRINT 2016 main menu, you have the browser option. Now, the browser displays on the left side by default and contains all of the menu items you need and commands to work with meshes within Rhino3DPRINT. Now, the dialog is divided into two sections. The upper section, you have a ribbon bar where you have various commands that are grouped under the Create tab, the Model tab, the Inspect and Modify tab, a Repair tab, and a 3D Print tab. Under that, you have the data tree, where all of the objects you create are listed here. Then we have a browser toolbar below that, and then also an information window. Now, this information window will duplicate for the command dialog when you select a command. So let's get started and open the file. From the Quick Start install path for Rhino3DPRINT 2016, you'll find a Rhino part called 3dmold.3dm. Let's open that. So let's turn some mesh wires on so you can see how many meshes we have in here and how complicated this part is. Over here in the browser, you see that we have 420 mesh objects, and they're all listed in the tree here. And we also have over 130,000 facet triangles in these collection of meshes. So you see that we got a number of meshes all over the part here. Now, what we want to do, anytime you load a mesh or create a mesh, like say from a point cloud, or if you import a mesh from an STL file, the first thing you really want to do is to do some diagnostics so you can understand what you have to work with. So let's go over in the Repair tab and we'll pick Diagnose. And we'll select all of our meshes and right click. And down at the bottom here for the Diagnose dialog, pick the Run Checks button. And what you see is we got over 30,000 open edges. Those have to be fixed. Like I've said before in previous videos, we can't 3D print a part that has open edges, so we've got to at least fix those. And some of these other items, it's not going to keep you from printing, but certain types of meshes you may want to try to smooth some of these out and straighten these out, but we're not going to really worry about them for this particular part. So let's close this and we'll go into the stay in the Repair tab, and to fix these open edges for this particular part, we'll use another command called Stitch and Close. And what this does is it examines all the meshes in the part and it'll close all of the open gaps in the meshes and combine them all into one mesh. So let's do that. Select Stitch and Close. Select all of our meshes. Right click and let it do its job. Okay, so what we have here is we have one mesh. Let's do another diagnosis and see if we fixed our open gaps problem. Select our mesh, right click, run checks. As you can see, we have 0 open edges, and that's what we want. So we'll close that. Now, one powerful feature in Rhino3DPRINT is the ability to do shelling of complex meshes. And what that does is it analyzes the mesh and allows you to create an offset of that mesh if you're going to be creating thin-walled parts, or if you want to have a mold with a standard wall thickness. If you don't want to model the entire wall thickness yourself, you can shell it within Rhino3DPRINT 2016. So let's do that. First of all, let's turn these mesh wires off so we can look at this a lot better and see the complexity of this particular mold part here. Okay, we'll go over into the Model tab and we'll select the Offset command. And we'll select our mesh, and in the offset dialog we're going to set the offset distance to 0.1, and we'll set the tolerance to 0.01, and we'll pick offset. Now the offset's done, and what you see up here in the data tree, another mesh was added. So we have our original mesh and we have the offset mesh. Now, the best way to look at this is to turn the offset mesh on and off, and you'll be able to see it better on the screen. So that's with it turned off, and then with the offset on, you'll see that the offset was added all around the mesh. Now, that's a standard 0.1 wall thickness around all the surfaces of the mesh. Now what I'm going to show you is the ability to split that mesh at any location in the z-axis and divide it into 2 meshes. So let's try that. Select Split from the Model tab. Select our 2 meshes. Right click. And you'll see on the screen you have a split plane that displays, and the split dialog provides a slider that you can move to make the split plane move up and down in the active construction plane. In our case, our construction plane is the XY plane, so the plane is moving up and down in the Z-axis. And if you want on your models, you can also pick a point on the model to split it, but we're just going to adjust this plane down a little bit, get it close to the base of this mold half right here. So that's pretty good. Now you also have the option here to cap or don't cap the results. What this does is, in a shell, if you're splitting a shell, you can choose to cap the ends of the split or leave them uncapped. Now we want to have a closed volume when we're done, so we're going to leave the cap results selected, and we'll pick split. Okay, so we got our split completed, and so what we see is we have 2 meshes in the data tree. So we had 2 meshes before. We had an inner mesh and an outer mesh, but now what you're going to see is we have a top mesh and a bottom mesh, and they're split at the split plane that we selected. So let's turn off the bottom mesh and take a look at this shell that we was creating. Now that's pretty nice. That was a complex set of meshes, and it evaluated that and made a really nice offset, and we split it. You can do this for mold halves if you have a parting surface or a parting line, and you can shell your parts and split them where you want them. That's it for this particular guide. If you need more information or want to find more videos, just give us a visit at www.mexsoft.com. Thank you.